So for lesson 16, Cramer's rule, again, it is another method that we can use for solving system of equations. It's kind of a non-typical method that we use, okay, just because it's different. It's using the idea of determinant, which, let's review that right away. Determinant of a 2 by 2, what was that formula that we used yesterday? Yeah, and what were the letters that they were? AD minus BC, remember that? And I said within the week you would have that thing memorized because you did it for lesson 14, but now you're going to do it several times today for lesson 16. So again, a method of solving system of linear equations by using determinants, that is Cramer's rule. And here is the box that the chart that they give you in the book. And this is perfectly fine if you want to put it in your notes. We're given two equations. Understand A, B, C, D, E, and F are just numbers. They're just coefficients. They're values. Notice we like to be in standard form. We haven't talked about this a lot, but standard form is when the variable's on the left.
I'm just going to go 1 second for me.
Yes.
Maybe 9 seconds.
All right. Go ahead and copy that down if you want.
Oh, yeah. Good. Okay, starting.
So again, Cramer's rule, and this is the setup. Understand when we did graphing, we were looking for our ordered pairs, the x and the y values. Well, that's what we're doing again. Okay, if we're going to solve the system, we got to find that x value. We also have to find the y value that makes both of them true. When you set this up, understand this big D is your determinant that you found yesterday. That was the AD minus BC, and that's using these coefficients here. There's your A, there's your D, there's your B, there's your C. Now when you set this up, here is a 2 by 2 and there's a 2 by 2. Easiest way to recognize this is to recognize that the first column is your X column, the second column is your Y. And again, X, Y. And you'll see why I say that here in a minute. So for example number 1, there's our two linear equations. We're actually going to solve this using our Cramer's rule method. Step number 1 is to find big D, which is the determinant of the linear systems. So big D, we find that by taking AD minus BC. So AD, your A value is this 3, your D value is that -3, minus the product of those two, B and C. -9 minus 8, we're coming up with -17. And you'll want to box that to save it. Next thing you want to do is set up your x and your y's. So go x is equal to big fraction bar, y is equal to big fraction bar. That -17, that big D, if you go back to our template, is our denominator. Big D doesn't stand for denominator, it stands for determinant. It just happens to be located in the denominator. So we can go ahead and fill that in. And now what we want to do is set up our 2 by 2s up on top. Now you can follow the templates, you can follow the E's and the F's and all these variables up here, but I'm going to actually explain it a different way. Again, we said the first column was x and the second column is y. You have to identify which variable you're solving for first. Okay? Here we are identifying we're solving for x. If you solve for that variable, you have to use the constants, which are these two values right there, and they have to go into that row that you're solving for. So if I'm solving for x, the constants -1 and 10 need to go into that x column. Now the y column will just get filled up with whatever the coefficients are for the y's. The y's are 2 and -3. It's going to be the same idea for when we solve for y. X, y. Which variable are we solving for? Well, it's the y variable. So our constants will go into that column, -1 and 10. But then in the x column will just be our x's, 3 and 4. And if you wanted to, you could go back and check the box to make sure they match up, and I will tell you that they do. So we already did AD minus BC once. Now we have to do it again because, again, that's what these vertical bars mean. Okay? Find the determinant, AD minus BC. -1 times 3 is 3. Minus 10 times 2 is 20. Same thing over here. 3 times 10 is 30. Minus a -4. So be careful with that minus sign. And you just simplify. You know, 3 minus 20 is -17. -17 over 17 is 1. And over here, 30 two-stroke method, 34 over -17 is going to get you -2. So if we were to graph these two lines, the intersection point should be 1, -2. Different, you know, most definitely. I'm guessing you have never seen this method before. But the nice thing about this method is, you know, did we ever have to use the variables? No. You know, if you think back to your elimination method and your substitution method, you know, you always had those x's and those y's. Well, this process eliminates those. So now it's just simply multiplication and addition and subtraction. If you think back to graphing, okay, when we solved these, we had our 3 scenarios that we talked about at the beginning. We had one intersection point. There it is, one unique solution. That was the example that we just did. We had the scenario where we had 2 parallel lines that never intersect, which was no solution. We also had the scenario where we had 2 lines that happened to fall right on top of one another, which was our many solutions. So understand, when you solve a system of equations, you're still going to have those 3 scenarios to go by. So this is where it gets a little bit tough to be able to identify those. Okay? If the determinant, the AD minus BC, the big D that you originally found at the very beginning, if that is not equal to 0, that means there is exactly one unique solution, which we determined that in the last example. We found that the point of intersection where those 2 lines intersect is 1, -2. There was that scenario. The other 2 scenarios come about when we get that big D to be 0. So let's go over this, let's do the no solutions part, this one here. Let's say we happen to have 2 lines that are parallel to one another. We don't graph it, so we don't see it. We don't know it right away. But we get that big D to be 0. But we also find that neither of the numerators are going to be 0. Again, neither of the numerators are going to be 0. So, you could have came up with this. Could have came up with 2 and -7. Notice both of the numerators are not 0. Therefore, if you get this case, it is a no solution for you. Suppose you get that denominator or determinant to be 0, but now you have at least one of the numerators is going to be 0. That's when we know that we have infinitely many solutions. That is this scenario right here. So an example of that could be 4, 0, comma 0 over 0. It could be that both of those were 0, 0 over 0 and 0 over 0, but notice the wording, at least one of those is 0. It is with these two cases we don't like Cramer's rule as much because it's kind of a funky rule that we have to remember. If it is just finding one unique solution, that's when it's fairly nice to use. So here we are. Let's do the process again. Cramer's rule to solve the two systems, or the system. Step number 1, we want to find the determinant big D. 3 times 2 will get us 6, minus 3 times 2, which is also 6. So notice our determinant is 0. At this point in the game, we now have narrowed down what our possible scenarios could be. If the determinant is 0, it can no longer just be one unique solution. You know right off the bat now that it is either going to be no solutions or many solutions. Now we just got to determine which one of the two it's going to be. X is equal to, determinant is 0. Y is equal to, determinant is 0. Can we fill this in? What's going to go in the X column if we fill in for the X variable?
5 and 8.
5 and 8. What's going to go in the Y? 2 and 2. Again, the variable that you solve for, X, that column needs to be filled in by the constants. Let's go over here. We're solving for Y. What's going to go in the Y column? 5 and 8. What goes in the X? If you can fill that in, now it's just a matter of doing your AD minus BC. 5 times 2 will get us 10, minus 16. 3 times 8 is 24, minus 15. Negative 6 over 0. And looks like 9 over 0. So, which of the two scenarios are we looking at here? The second one. That was this one. We found our big D to be 0, but neither of the numerators are 0, therefore, no solution. I'm going to give you a head start to B, and then I will meet you at the end. Find big D. Set up your X is equal to, set up your Y is equal to. See if you can figure it out. And if you get really good at your rules, do I need to go any further at this point? You don't, okay? Because if you go back to the wording of it for the last scenario, if at least one of the numerators is 0, then you have many solutions. You know, I think it turns out to be that this one just happens to be 0 over 0 as well. But again, this one alone tells us it's that last scenario, many solutions. Before you attempt these two problems, A and C, I want you to review just a little bit with me. Many solutions. We had these terms called consistent and inconsistent and dependent and dependent. Let's review those. If it's a many solution scenario, is it consistent or inconsistent? Consistent. Why? Well, there's at least one solution here. Now we move on to the next question. Is it dependent or independent? Dependent. Why? Because there's more than one solution. Independent is when there's one solution. Let's review no solutions. No solutions. Consistent or inconsistent? Inconsistent. Inconsistent is when there's no solutions at all. And it's just like the irrational numbers. Once you identify it to be irrational, you don't have to classify it any further. If we classify this one that we found, consistent or inconsistent? Consistent because there's at least one. Independent or dependent? Independent because there is one solution. Exactly one. Okay. And they talked about those down here as well. Okay. You have more than enough knowledge to tear into it. I want you to attempt A and C. And I will tell you, it is possible to get a fraction for one of your values.